Additional to the security of data, we are going to discuss now what we call data integrity. Coming up for our discussion, and of course our key discussions for this data integrity, how are we going to validate and verify data and to help protect the integrity of data? We are going to look into the different methods of data validation and of course methods also on data verification. Let's talk about some brief description about data integrity, and as always been discussed and in some numerous encounters with respect to definitions and descriptions of data integrity. Stored data or data stored in a computer should always be accurate, we have here, consistent, and of course up to date. There are only two methods used to ensure data integrity. We're going to look into this. We have here the data validation, at the same time data verification. The accuracy or integrity of data can be compromised. We just discussed that one with respect to data security. So during the entry of data and transmission of data, there could be compromise situations wherein the data might be the data will not be accurate when it is being transmitted or during the entry. Another one is we also have a discussion last time with respect to malicious attacks on the data, especially the use of malwares and the malicious hacking. And of course, accidental data loss caused through hardware issues. Alright, now what is this validation? How do we validate the data? Okay. Validation is a method of checking if the data entered is reasonable and within a given criteria, but it cannot check if data is correct or accurate. So let's take a look at a good example here. If somebody accidentally enters their age as 62, well, 62 is considered as a reasonable data, okay, but we cannot check whether it is accurate or correct. So accidentally, instead of 26 years old, what has been written is 62 years old. For the format check, it's actually the data type that was used for entering a legal age there is 62 is still valid. Only that instead of 26, what has been entered is 62. Okay, this value is still reasonable, but it is not accurate or correct as there is an accidental misentry or mistyping of the correct age. Of course, validation is also being carried out by computer softwares. There are four common types of data validation. As you can see here, there is what we call the type check, range check, type check, range check, format check, and length check. The type check is, of course, if it is an integer, then you can make use of a whole number only, integer. Okay, let's say integer type, let's say the age there a while ago is 26. It's not 26.1 or 26.2. If it is a floating point value, use a floating point value. So it conforms with the data type that is being used, and we already discussed these numerous types of data ranging from integer, float, character, string, and boolean. Okay, the range check is for example the age is from 0 to, let's say, what is now considered as the life expectancy right now. I think 75. It would be very great if I will reach the age of 75. Range check is whether it belongs to the lower and upper limit or to the lower and upper bounds. Okay, so from here, lower and upper bounds, from the word alone, range. So there is a upper and lower limit. All right, format check is of course one good example here is with the use of the date format or the birthday format. Okay, so the time format also. So that is also one way to validate the data. And of course, the length check is one good example that was given here is a telephone number, or we also have our cell phone number. Another one is the plate number that is being used in the cars, or maybe the license number that we are getting from our license. So there is actually a prescribed length of how many numbers are going to appear in our identification. All right, moving further, there is also what we call the presence check. Okay, you need to check whether you entered correctly what you call this one an entry. Maybe you are filling up a Google form, or you are doing what we call online application. So one good example here is you need to carefully enter your passport number. Okay, nowadays is a very good identification, yeah, all throughout the world. So using our passport number. The other one is existence. Check if the data in a file or a file name actually exists. So these are just a very common way to validate whether the data exists or not. Okay, and we also have what we call the limit check. Okay, checks only one of the limits, such as the upper limit or the lower limit. So it is actually checking only. So it depends whether the criteria is the lower limit, then it would be the lower limit. If it is the upper limit, then it is definitely the upper limit. Now, as we continue, there is also what we call consistency check. Checks whether data in two or more fields match up correctly. Okay, so all throughout the data should be consistent. If you make use of the name, let's say John Doe, and then if this John Doe will be existing in another table or another column of your data, then John Doe should exist there. And if John Doe is considered as a male, since from the name itself is actually considered he is actually considered a male, or a Mr. John Doe, then definitely, yeah, if you're going to describe or give in what would be the gender, so it should be male. Okay, it should be consistent. It should not exist in another column or field or another row that Mr. John Doe is a female. The other one here is a uniqueness check. Okay, checks that its value entered is unique. Choosing the username. Okay, it's a social networking site, but the username already exists. This is usually what you call this one, a verification. Is a kind of validation check whenever we're going to sign up, or signing up to a new website, or signing up to a new organization. Okay, there is what we call uniqueness check, that if the user ID that you entered has been taken already, so there is a warning from the user that the user ID has been used, so you need to create another one. Okay, now under verification, another way is verification. We need to, after validating the data, then we can also verify. I mean, these are the two methods that is being used to check whether the data that we are using is accurate, up to date, or it has this considered as property of considering as the data is of integrity or accurate. Verification, so you check whether when you manually enter a data, so you need to check one by one, look on the screen or check on the Google form. Okay, while entering, so you need to check, especially the spelling, if you mistype some characters. Okay, and then of course verification during data entry. When data is manually entered into a computer, it needs to undergo verification to ensure that there are no errors. So under this method of data integrity, verification also has subcategories. 3 ways to check whether there are some ways to check whether the data being entered is considered as what is accurate or up to date, or they are correct. So we have here double entry, visual check, and of course with the use of the check digit. There would be a lot, but of course the most common is the most common that I'm going to discuss. Yeah, so we have here the double entry, so check whether there is a double entry of the data, so the data is being entered twice, so it's very obvious. Yeah, so need not to discuss this in detail. Okay, double entry. Visual checking, this is one way to check with our eyes. Okay, what is on the screen when you're going to compare it on your original documents or original data should match. Okay, there should be consistency. That's a visual check. Now, check digit, which is one of my discussions in the in your IGCSE. I'm going to give an example of this, and one of the most important application of check digits is the use of the ISBN here. Okay, especially our textbook. We could check whether the number that was being placed on our textbook is valid or invalid, or usually in the barcodes. Okay, the check digit there is used to check whether the data, okay, the barcode is correct, or the book number is was printed, okay, legally, or it was registered legally. All right, so check digit, let's take a look at this check digit, and I already have that one. So there is what we call a process or a check digit algorithm that is always being used whenever you want to verify that the last digit here, so I'm actually, the last digit here is the one that is going to be verified. Okay, the number 5 here, this is for verification. Okay, if this number will appear during the computation, then the book number here, ISBN stands for the International Standard Book Number. Every book has this one. Okay, and it also has its own barcode. So let's take a look at the it's just a 4 steps on how to check whether the last number here is valid or invalid. The first one here is you add all odd number digits together. Okay, by the way, the ISBN for textbook for International Standard Book Number is usually 13 digit. Okay, it's a 13 digit number, and the 13th digit, this one, the last digit there, is actually the check digit that we are going to verify. So that is what we call the check digit. Okay, check digit. All right, so you're going to add all odd numbers digits together, add all even numbers digits together, and then multiply the result by 3. Then you are going to add the results of step 1 and step 2, then divide it by 10. Actually, division by 10, or this is modulus, okay, mod 10. So what is being returned is usually the remainder. Now let's take a look at the number here. If I'm going to number here, this is 1, this is 2, 3, we have here 4, we have here 5, this one is 6, 7, we have here 8, 9, 10, 11, and 12. We are not going to make use of the last digit for the computation. So the first one is add all odd numbers digits together. So that is, let me use another color here, add numbers. So that is 9 plus 9 plus 8. So this is correct, 9 and 8. And then 5 is plus 1. I did not include already here 0 because that is plus 0. So I don't know, plus 8, sorry, plus 8, that one is 7. So this one is plus 1 plus 8, then plus 3, we have your plus 3, and your 11 odd number digit is 11. The number there is 7, so plus 7, so that is equivalent to 36. Now the next process there is add all even numbered digits together and multiply the result by 3. So we're going to make use of another color here. So this one is 7, that is even number 2. Your 4 is 1, so this is 1. Your 6 is 0, 0. I hope you can follow with the cursor. And then your numbered 8 has a value 7, and then 10 has a value 3, and 12 has a value 5. So you add all of this, that is 23 times 3, that is equivalent to 69. That's step number 2. The step number 3 now is add together the results of steps 1 and 2, steps 1 and 2, and then divide the result by 10. So we're going to get the modulus. So 69 plus 36, that's equivalent to 105. And of course, the last we have here, the last process is you get the modulus. Modulus is, it will always return the integer remainder. So if you're going to do like this, 105 mod 10 or 105 percent sign 10, percent sign is also a symbol for modulus. So very obvious that the remainder is 5, and then you need to take away the remainder of the division from 10, leaving the check digit. So the remainder is 5, and the last step now is you need to subtract 5 from 10, which is equivalent to 5. And as you can see here, the check digit is 5, in which it corresponds to our computation of the algorithm for check digit. All right, so that's how to get the check digit for the ISBN. All right. There is also a verification during data transfer. So you need to verify electronically. Okay. Of course, if you're going to transfer it online, so there should be a verification. So this is to prevent the possibility of data corruption or even data loss. Checksum is simply getting the sum of all all the values or the blocks of data. There would be a calculation there, and I think this was already done during the IGCSE. So you just need to follow the checksum algorithm, and if the value that was used, or the number of blocks of data was actually the same to that value whenever it is being sent. So meaning, if for example the blocks of data is 100, okay, in the receiving end there should be 100 blocks of data. So that is checking or verifying that the data was transmitted without any corruption, or the data was not corrupted. Another one is parity check. So this is a method. This is not something new to you. A parity check is another method to check whether data has been changed or corrupted following transmission from one device or medium to another. So of course, yeah, there is an allocated parity bit, usually at the 8-bit of the data, of course, when the data is being converted into its equivalent binary. So there are two systems that is being used, even and odd parity. Okay, so let's take an example here. If this is the parity bit, usually at the end or at the last digit, okay, at the 8-bit of the binary number. For example, if what is the even parity? So let us consider this number here, this binary number. If we are going to implement even parity here, okay, if the byte is using even parity, then the parity bits needs to be 0, since there's already an even number of 1 bits. What does it mean from this previous example? If we are going to make use of even parity here, these values here, the question is, what would be the bit here? Okay, the bit there is either 0 or 1, but it depends if we are going to make use of even parity. So the value here would be equivalent to 0, since if you count the number of ones present in this binary number, only 4, and 4 is considered as even number. Okay, even parity has an even number of bits. Odd parity have an odd number of 1 bits. So that is the discussion there. So from here, why the parity bit here is 0? Because there are actually four ones here already. Number of ones is 4, and 4 is even. And then if we are going to implement add parity, definitely this one would be equivalent to 1, because previously there are 4 numbers. Okay, for 1s. To make it odd, we need to make the parity bit as 1, and that would be counted as 5. Okay, 5 1s, and that is considered as odd parity, an odd number. And of course, it's not only limited for a single, an 8 bit value or 1 byte long data, but it could be in a considered as blocks of data. Okay, so the parity bit here, there is a parity bit here. Okay, and then there's also a parity bit for this area. 9 bytes. Okay, if 9 bytes of data had been transmitted, so same, each byte should be if it is considered as a blocks of data that is going to be sent. Okay, so that depends whether what parity bit we're going to use. So agreement has to be made whether odd or even parity. So another byte known as the parity byte has also been sent. So if there is what they call this one, blocks of data. So if in one time that you're going to send a blocks of data, let's say 9 bytes, there is an additional parity byte. Okay, so this is a parity byte, this is also a parity byte. And this byte consists entirely of the parity bits produced by the vertical parity check. The parity byte also indicates the end of the block of data. Okay, so if for example here, what has been made is even parity 1, 2, 3, 4, 5, 6. So byte 1 here is will be transmitted correctly because there are 6 numbers already. Then if you check it on the vertical on the column, be sure that it is also even numbers, since we are going to make use of what we call even parity. Okay, this one, even parity. So let us check. This one is 1, 2, 3, 4, 5, 6. There are also 6 numbers. So across, you need to check whether it is an even number of ones. If not, then there would be an error in the transmission of the data. Alright, so that ends our discussion about data integrity. I hope you learned something. Thank you very much.